So here we go again, and this talk is called Tolman's interpretation of Einstein's relativity versus Bergmann's interpretation. So I'm going to point out an example of Einstein's relativity being interpreted in two different ways. It's because Einstein's relativity is not a properly defined theory that people end up having their own personal interpretations, thinking that is relativity, but it is really their version of relativity and not Einstein's relativity, because Einstein's relativity is vague. The information source I'm going by is this paper by Burniston-Brown, What is Wrong with Relativity, and that was published in 1967. It criticizes Einstein's relativity, and being published in 1967, it was a time when it's a bit more free to be able to publish papers criticizing Einstein's relativity in science journals. It's a bit more difficult now. According to Burniston-Brown, the Cuckoo process is why Einstein's relativity does not make sense to many people. So what Einstein's doing is interpreted by Burniston-Brown is a cuckoo process. And so he says this is only possible, this is when you're dealing with Einstein's relativity, and that's by assuming Newton's second law and the conservation of momentum and then modifying them. It also makes clear how Einstein could call Tolman's account or theory, that's 1934, definitive, and also praised Bergmann's treatment, which is 1942, when the former author thought length contraction real and in principle observable, whereas the latter seems to have thought it's only an appearance. And so I'm going to look into more detail into what's being pointed out here. So this is the book by Tolman. It's called Relativity, Thermodynamics and Cosmology. Richard C. Tolman. And this is Tolman according to Wikipedia. He was an American mathematical physicist and physical chemist who made many contributions to statistical mechanics and so forth. And he dealt a lot with Einstein's theory. So here is a review of Tolman's book in Science, that's a journal, volume 80, number 2077. It's a bit more than half a page, but it's a very short review. It's a review by Einstein. So I'm going to expand that image. This is the image expanded, and it's written in German. A lot of the journal is written in English, but this review is written in German. Einstein was more comfortable dealing with German than he was with English. This is my rough translation of what Einstein is saying. So Einstein says this: Tolman's book is a reliable, detailed and clear presentation of the entire contents of special and general relativity. With a sharp, critical sense, the author limits himself to a phenomenological presentation, elucidating the connection between gravity and electromagnetic fields, as well as the structure of matter, using the methods of the theory of relativity. This seems entirely justified, since none of these fundamentally different experiments has so far led to any convincing results. And you can read the rest of it if you like. So moving on now, hopefully you've had a quick reader and read the rest of that to the next. So this is what continues on. Leaving you a few moments to read this in the what Einstein referring to there with that funny arrow thing, that's the cosmological term. Maybe hopefully you finished reading that. And so moving on to the next bit. So Einstein praises this book by Tolman, and in this book Tolman says the following. This is the page, and in it Tolman is claiming length contraction is a real physical effect. If I go down to the bottom bit, he's saying, this is Tolman saying, except in the two postulates of relativity, this result may be called the Lorentz contraction, that's the length contraction, is to be regarded as an entirely real one, which, except for experimental activities, could be verified by direct observation of the kind just described. Right, moving on. Next, this is the next book. This is the book by Bergmann. It's called Introduction to the Theory of Relativity, with a foreword by Albert Einstein. This is Bergmann. He's a German-American physicist, best known for his work with Einstein on unified field theory. And so Einstein's unified field theory was abandoned by most people in mainstream physics. They just stuck with quantum physics when Einstein started complaining about the direction that quantum physics was going with. So this is the foreword by Einstein, now expanding that. So this is the foreword by Albert Einstein, and it says, although a number of technical expositions of the theory of relativity have been published, Dr. Bergmann's book seems to me to satisfy a definite need. It is primarily a textbook for students of physics and mathematics, which may be used either in the classroom or for individual study. And I'll give you a few minutes to read the rest of that. So hopefully a quick reader. And moving on, the rest of what Einstein says is the following. Einstein says, I believe that more time and effort might well be devoted to the systematic teaching of the theory of relativity than is usual at present at most universities. And so it's strange, but at the time when Einstein was alive, there wasn't really that much interest at university to deal with relativity. Anyway, the praise by Einstein and Bergmann in his book says the following. Bergmann tackles the issues of such things as length contraction by the issue of simultaneity. and he's referring to it earlier, and he says the above considerations help us to remove the apparent contradiction between the law of propagation of electromagnetic waves and the principle of relativity. If it is impossible to define a universal time, and if the length of rigid rods cannot be defined independently of the frame of reference, it is quite conceivable that the speed of light is actually the same with respect to different frames of reference which are moving relatively to each other. So carrying on, going back to what he's talking about two thunderbolts hitting a train and the ground and leaving permanent marks, and it's happening at two ends of a length. So he's talking about at the instant that the thunderbolt strikes at point A and a star, these 2 points coincide, and that's according to a certain observer, but not necessarily to another observer. So he gives us this diagram. You can see on the top one the 2 lightning bolts hitting the points, and the train is then moving. And he gives an explanation of this, and you should note the word appears simultaneous, and that's according to a certain frame. So what we're talking about here seems to be appearance. The train is moving and you have the appearance according to Bergmann. So the way that Bergmann is talking about it, there is an appearance of length contraction due to the issue of simultaneity in special relativity, i.e. observers cannot agree on events being simultaneous to one observer. 2 events might be simultaneous, and to another observer those events are not simultaneous. Thus length contraction in Bergmann's description is an appearance, or seems to be an appearance, as Burniston-Brown points out. So really Bergmann seems to be talking about an appearance. He's not saying it's a real physical effect, but he's pointing out it's an appearance of what people observe. It cannot be both appearance, which is like an optical effect, and a real physical effect of length contraction. It's got to be one or the other. So looking to a decision for Einstein to what relativity is referring to, and Einstein endorses both Bergmann's view and Tolman's view, and that's a contradiction. Einstein's relativity is built up from many contradictions like this. If you've got things like twin paradox, which seems to be a contradiction, you've got other things which come into it which seem to be contradictions, and you're supposed to just accept that. But in this case you've got Bergmann and Tolman who seem to be saying different things, and Einstein is going to accept both things. So how many of these contradictions are you going to accept? So how does Einstein not notice things like this? I suspect, being German, Einstein's German, he did not have a proper understanding of English. So he did not notice such subtle things as the difference between an optical effect versus a physical effect when it's being discussed in English. He did not notice the difference between those talking of appearance of length and traction versus those talking of an actual physical contraction of the object. Thus we get confusion like this in the relativity literature, leading to what Burniston-Brown points out, that Einstein's relativity is not a definitive theory. People claim their belief in relativity, but that is an umbrella term for them believing different theories. You can believe a theory where Einstein's relativity is merely dealing with appearance, and what you got is not a physical effect when it's length contraction, or you can believe that length contraction is actually a physical effect. And Einstein's relativity is vague on what it's supposed to be. If we go to more modern times, then we've got extra problems such as this, that in the physics world it's claiming that length contraction is invisible anyway. So the problem becomes, what was Einstein originally meaning his theory to be about? Was it appearance, or was it an actual physical effect? He didn't clarify properly. And what has the theory now changed into? So picking up on what Burniston-Brown says, he says Einstein never wrote a definitive account of his theory. It's a vague theory. And that seems to be one of the core problems with Einstein's relativity. It's just something vague that gets subjected to lots of different interpretations by the mainstream. And Einstein's relativity could be said to be neither fish nor fowl. And that's a way of saying that it's neither one thing or another. It's something vague. Burniston-Brown decides that Einstein's relativity is using a cuckoo process. Those who believe in Einstein's relativity just ignore the problems with it. And that's it. That's the end of this talk. Thank you.